Okay. So U-substitution is when we're trying to use the chain rule inside integration. So we would use x squared plus 1 as my chain built into this. So we've already, I apologize for not starting the video on time, but what we're trying to do is trying to turn all of the x's into u's. Or as Kevon said, turn u into an x, which is not good relationship advice. You stay single very long there. Anyways, so u is equal to x squared plus 1 here. All right, that would be the part that would be the chain piece that kind of messes up our problem. And we said we're going to take the derivative of u with respect to x. So if we take the derivative of u with respect to x, what would we get out? 2x. Okay. There's going to be two ways to kind of attack this problem. What I'm going to do is I'm going to do it a slightly different way than I will usually do it first. And then we'll move on from there. So this is du over dx. One of the things I can do is I can actually take this dx and multiply this term out. So I can call this du is equal to 2x dx. And what I want you to realize here is now I can replace quite a few of these things. I can replace the x squared plus 1 with a u. So this becomes u to the 5th. I can also substitute out the 2x dx with the 2x dx and replace the 2x dx with a du. What we get is a problem that has one variable. It's only u's now. And do I know how to take the antiderivative of u to the 5th? Certainly. U to the 5th is u to the 6th over 6 plus c. Now the problem started out in terms of x. We should probably finish it in terms of x. So I can replace the u with, we can call this 1/6 x squared plus 1 to the 6th plus c. Now I did something that I'm not a huge fan of here, and it's going to be in this step, in the next problem, this step right here. And in the next problem I'll show you how the other 5 calculus teachers in the district teach it, which turns out to be different than the way that I understand it and did it. So Miss Bruce, Mr. De Leon, Mr. Osagura, Miss Mull, a whole bunch of them. Yep. You should. She taught you twice. 3 times, you're right. 3 times. Holy moly. All right. So take a look at the next question. The next question, what I'm going to do is I'm going to do this in 2 different colors. I'm going to do the way that the rest of the district teachers will do it in red. I'll do it again in blue the way that I understand the problem. I don't care which way you use. Okay? I will typically do this in the method that's going to use the blue pen. But I just want you to kind of see where they come from and where I come from, and there's a slight difference on how you attack the problem, but it all winds up being the same in the end. So we're looking at the integral of x squared times 2x cubed plus 5 to the 4th dx. I look at that. I really don't want to have to multiply 2x cubed plus 5 4 times and then distribute an x squared into the problem. All right? I don't hate myself that much. So I look at this problem and I say, would I use chain rule here? Sure. What would be the chain portion in this problem? 2x cubed plus 5. And if I take the derivative of the 2x cubed plus 5, will I wind up with an x squared eventually in this problem? So what I'm asking you is if I take the derivative of u, which is du dx, what will I get? 6x squared dx. Okay? Now this is where things get a little bit weird. And so this is the step that's going to be different between where the other teachers do this and the way that I do this. So what they'll say is we know that du is equal, sorry, I put a dx in here and I wasn't supposed to put the dx there. That's habitual. So du is equal to 6x squared dx, right? So I look at my problem, and I realize I have my u here. I have 6x squared dx. I only have x squared dx in my problem. So I can make it into a 6x squared. Watch. It's 6x squared. Can I do that? Why not? Why? Because the math cop said so. Okay, math cop, tell me why. Why can I not just multiply this by 6? Yes. Okay. Focus back in, because what's going to happen is kind of weird here. And I know it's fun to be silly, but we need to make sure that we're actually on point here. Why can I not multiply that by 6? Wasn't originally in the problem. I have changed but I need the 6. I can't do this problem if I don't have a 6x squared. So what can I do to make this work? What if I do this? If I multiply it by 1/6 and by 6, have I really changed the problem? What did I multiply by? If I multiply by 6 times 1 over 6, what did I really multiply by? Multiplied by 1. So if I look at this problem, what I've done is I've kind of rearranged this problem. I've got a 1/6 here. I still got my 2x to the third plus 5 to the fourth power here. But now what do I have? I have a 6x squared dx in my problem. And when I do that, I can replace the 6x squared with the du. And I can replace the 2x cubed plus 5 with a u, and call this u to the fourth power. Antiderivative of u to the fourth, and now we look, this is all in terms of u, there's no x's, no nothing like that, so we're good to go. Antiderivative of u to the fourth is u to the fifth over 5 plus c. I need to turn this into a problem back in terms of x, so I can call this 1/30th, and u to the fifth is going to be 2x cubed plus 5 to the fifth. So what I did in this problem is I had to go back to the original and multiply it by a form of 1 so that I had the correct constant. So instead of having just an x squared, I had a 6x squared. And that is something you are allowed to do in these problems. Now what I do is slightly different. Okay, you remember yesterday when we started talking about these problems, remember I made a statement earlier how we do k times f of x dx is really equal to, and I can take the constant and factor that out. You remember I told you I'm going to abuse that? Let's abuse. I'm going to follow the same exact pattern in the way I would attack this problem. I'm going to call that u is 2x cubed plus 5. Nothing changes. I'm going to take the derivative of u with respect to x. I'm going to get 6x squared, except I'm not going to solve for du. I'm going to solve for dx. The strength on this particular concept, so this builds a really good algebraic substitution concept, gets you used to multiplying by 1, which is a skill we need to know. This particular process, what this does is it allows me to take this problem and call this u to the, what was it, fourth power? Times x squared times du over 6x squared. So what did I do here in my blue side? I canceled out just the x squared, and I replace the x squared here, and the x squares cancel out, and I'm left with a du over 6. And I can take that over du over 6, and I can factor out the 1/6 from the problem, right? Now, if I do that, where am I back to? Very different algebraic paths to get to the same exact outcome. Do I care which one you use? No. I'm going to open that up to when we get to the next problem. All right, so the next problem, I am going to do it the way that I intend to do it, so that just so that you're aware of that. So I look at this next problem. X times the square root of x squared plus 3 dx. Would I use the chain rule here? If I took the derivative, would chain rule get used? Certainly, because we have x squared plus 3 inside a square root. So, what is my u going to be? My u is x squared plus 3. Yeah, if you got to 2x, you were already taking a step ahead, which is okay. Now, I am going to ask, do you guys mind if I take a little shortcut here? I'll show you the shortcut. du is equal to 2x dx. What did I do here? Yeah, I skipped the writing the du over dx because eventually I'm just going to multiply that over anyways. So if du is equal to 2x dx, then dx is equal to du over 2x. One thing I will point out, I'm writing a lot of extra steps here. Normally I'm not going to show this step, but I want you to see it as we go through so you can kind of build what I'm doing mathematically. This is all just algebraic manipulation. I take a look at my problem. I get the integral of the square root of x squared plus 3 times x du over 2x. And what happens here? X's cancel. I'm going to take that over 2. I want to pull that out. I'm going to change x squared plus 3 into, you'll also notice I turned the square root into the 1/2 power. What is the antiderivative of u to the 1/2? U to the over 3/2 plus c, or I would actually prefer you skipping straight into this. Division by 3/2 is the same thing as multiplication by 2/3. Your final answer becomes 1/3 What do we think? Not terrible? All right. Ladies and gentlemen, you try the next question. I'm going to pause the video here so that we don't have an awkward multiple minutes of silence. All right, so the answer's up on the board. So if you're still kind of going through it, what I want to do is I want to kind of walk through the steps. Follow along. If you got the right answer, obviously you're looking pretty good. Follow along and see if you did all your steps the way you're supposed to. Remember, there's kind of that weird step that's going to happen in the middle. Did anybody use the, how many people used the method that I had used as opposed to the method that the other teachers would use? How many people were my method people? How many people were the other teacher version? Okay, cool. When I get there, I'll try to make an accommodation for that so you can see it. All right, so I looked at the problem. Everybody should be under the same exact u step. Everybody should have the same exact u. That's the part that's inside the square root. That's the piece that needs to be u subbed out. So I take the derivative with respect to u to get 6x dx. if you were here, you had rewritten your problem something like 1/6 the integral of 6x dx over the square root of 3x squared plus 4. Right? So if you were one of those people, that's where you stopped. If you did it the other way, you called this dx is equal to du over 6x. So if you stopped here, you called it this. If you stopped here, you called this the integral of x times du over 6x over the square root of 3x squared plus 4. And you canceled out your x's. Either way, after you've done this in either one of these methods, you should have gotten 1/6 the integral of u to the negative 1/2 du. This becomes a u, and because it's over the square root, it becomes a negative 1/2, and then your u falls out depending on however you deal with that. Pretty good? Antiderivative of u to the 1/2 is 2 times u to the 1/2 plus c. 2 times 1/6 is 1/3. I don't know why I'm rewriting this. 2 times 1/6 is 1/3. U is 3x plus 4, still to the 1/2. There's your plus c. Whoo! U-substitution, what do we think? All right. Then let's have some fun. No, what that's doing is it's trying to make the variable we're changing with respect to be a one-to-one change with what's in the problem. If this does not match with this, we actually cannot do the integral of that problem with that variable. So if this were u to the negative 1/2 dx, that's completely illegal. We cannot do that problem. So we do need matching variables. It's at least in the problems that we're looking at right now. Further on in your upper level math classes, when you start getting into Calculus 3 and you start looking at multivariable problems, there becomes some slight differences on how we can attack the problems. You knew this was coming. Cosine 3x dx. If you were to take the derivative of that, would you use the chain rule? You know how to take the derivative of cosine of 3x? Yes? What is cosine of 3x? Oh, it's negative sine 3x times 3, which means you use the chain rule. So, there's a chain rule here. And my u portion for the chain rule would have been 3x. If 3x is my u, then my du is 3dx. Now, I'm going to actually skip over some steps here because this is where I would typically, from this step, what I would typically do is I'd realize that that 3 is going to get divided underneath my du. I'm going to call this 1/3 cosine of u du. And that's eventually where you want to get to. Now you may still be using, whichever method you use, whether you're writing this as dx is du over 3, or whether you're multiplying dx by 3 and then multiplying a 1/3 out here. Whichever one of those two methods you're using, eventually this winds up turning into 1/3 the cosine of u du. I got u's, everything's good, all my variables match up. You just have to tell me what the antiderivative of cosine is. Sine. Of course, I don't want the sine of u, I want the sine in terms of x, so this is going to be 1/3 sine of 3x. Ladies and gentlemen, you're done. Again, I'm going to give you a couple minutes to try the next one. I'm going to put the video on pause so that we don't have an awkward couple minutes of silence. The integral of x squared secant squared x cubed dx. So the answer's up on the board. 1/3 the tangent of x cubed plus c. One of the things that I do want to point out is that you remember when you all thought I was crazy when I told you you'd be U-substituting most problems in your head? And then you started doing U-substitution, or not U, but chain rule in your head? Yeah, it takes a little bit more time, but eventually there will be some basic U-subs. Now this would be considered a basic U-substitution problem. There will be some U-substitutions that, oh heck no, you're not going to get it right the first time. By the way, I am going to tell you, U-substitution, these are pencil problems. Because there will be some times where you will select the wrong U. There will be some times where you will select the wrong U multiple times, and there will be some times where you think it's a U-substitution problem, and it's not. That it will be completely impossible to use U-substitution for the problem at hand. Yeah, there will be some times that you can U-substitute, and sometimes you cannot. So, we go through this problem. Hopefully you selected your U as x to the third. Do we need to see this walked through at this point in time? We feeling pretty good? People got some confidence going now. All right, let's go kill it. No, that's not the goal. Our goal is never to kill confidence, okay? Take a look at that problem. Sine cubed 5x, cosine of 5x, dx. What do you think? There will never be a problem where I will give you two u's. Every problem should be done with a single u. Okay? How many people are going u equals 5x? Sounds pretty good. Yeah, sounds great. So what would du be? 5 dx. Okay, cool.
Yes.
So if that were the case, what would we get? We'd have 1/5 the integral of the sine cubed of u cosine of u du. Well, I've got rid of the x's. That's cool. Ladies and gentlemen, what's the antiderivative of sine cubed of u times cosine of u? Can't do that. I don't have anything that says that. So, if we can't, what if we do this? Could I possibly do Is that legal? Why not? I can split the integral only over what operations? Addition and subtraction. I cannot split an integral over multiplication. And just like in a derivative, I can take the derivative of sine of x, but I cannot take the derivative of sine cubed of x. That would have been a chain rule, right? What that tells me is, looking at this problem, you picked the wrong u. It's what? Sine? Sine what? You have to pick more than just the word sine. Sine's just an operator. Sine cubed? So we try sine cubed of 5x.
That's also wrong. I'm not right. Explain. Those are wrong. It's wrong. It's wrong. Everything's wrong.
Okay. If I do this, I have a cosine of 5x. That'll cancel out with the cosine of 5x. And I have a sine squared of, oh, but if the sine squared, what's the sine squared going to cancel out? Because all three of those sines have been turned into a u. So that did not work. Remember, my goal is to pick a u that after I take the derivative of it, it may be able to cancel something out. No. I'm running out of colors. Sine cosine is going to give us a product rule. Do we really want to have product rule show up? Okay, you said there was why did you pick the 5x? Would we have to chain rule that question? Is there another chain that we could use in this problem? What if we just did the sine of 5x? Well, because, and it's a good question. No, honestly, why would we use the sine of 5x? I have that third power, so if I were to do that, I'd have to take the third power first, and then we'd have to take the derivative of the sine. The sine of 5x is a chain to the cubed. Agreed? What's the derivative of the sine of 5x? Oops. Thank you. Times 5. Maybe. Or dx would equal what? Du over 5 cosine what do you think? I have this 5, so that would give me cosine of 5x would cancel out. Ladies and gentlemen, your job is to come up with the rest of the answer to this particular question and do questions 1 through 6 on the homework assignment. 1 through 6. Have a fantastic day.